Hello students, welcome to this lecture One Circles. So in this lecture we'll continue NCERT exemplars problem One Circles. Okay, so let's start. See there we have question number one. So in question number one here we have out of the two concentric circles, the radius of outer circle is 5 centimeter and the chord AC of length 8 centimeter is a tangent to the inner circle. Find the radius of the inner circle. Okay, so the, uh, these are all short answer type questions. So let us solve this problem. So let C1 and C2 be the two circles having same centers. O. AC is a chord which touches the C1 at point D. Okay, so this is the figure. So this is actually our circle C2 with radius O, and this is circle C1 with radius with center O. Okay, so here now we join OD, and also OD is perpendicular to AC since what is the radius, and this what is radius, and AC is the tangents passing through this point of contact D. So this angle is 90 degree, and now this triangle OAD or AOD, this is right angle triangle, and in right angle triangle AOD, here OA square, this is equal to OD square plus this is equal to AD square plus DO square. So by Pythagoras theorem, hypotenuse square is equal to base square plus perpendicular square. So it implies DO square, this is equal to 5 square minus 4 square, that is equal to 25 minus 16, and this is equal to 9. So it implies DO, this is equal to 3 centimeter. So DO is equal to 3 centimeter. So radius of this inner circle is 3 centimeter. Okay, so the radius of the inner circle is 3 centimeter. So now let us move to next problem. So in next problem, here we have two tangents PQ and PR are drawn from an external point to a circle with center O. So here we have to prove that QORP is a cyclic quadrilateral. Okay, so let us see how to solve this problem. So here given two tangents PQ and PR are drawn from an external point to a circle with center O. Okay, so here from this external point P, we have drawn two tangents on this circle, two tangents to a circle with center O. So now to prove that QORP is a cyclic quadrilateral. So since PR and PQ, they are tangents. Okay, so PR, this is perpendicular to OR, this is perpendicular to PR, and OQ, this is perpendicular to PQ. Since if we draw a line from center of a circle to its tangent line, then the line follows perpendicular. So therefore angle ORP, this is equal to angle OQP is equal to 90 degree. Okay, and hence angle ORP plus angle OQP is equal to 180 degree. Okay, so quadrilateral QOPR is cyclic quadrilateral. So if sum of opposite angle is quadrilateral in 180 degree, then the quadrilateral is cyclic. Okay, so here the sum of angles QRP plus QOQP, they are equal to 180 degree. Okay, sum of opposite two angles of this quadrilateral is equal to 180 degree. Therefore, this quadrilaterals ORPQ is a cyclic quadrilateral. Okay, now let us move to next problem. So in next problem, here we have to prove that the center of a circle touching to intersecting lines lies on the angle bisector of the lines. Okay, so let us prove this. Prove this. So here given two tangents PQ and PR are drawn from an external point P to a circle with center O. So here we have to prove that center of a circle touching two intersecting lines, one the angle bisector of the lines in angle RPQ. RPQ. So construction join OR and OQ, and in triangle POR and triangle POQ, here angle PRO, this is 90 degrees since OR is perpendicular to RP. Okay, and this angle PQO, this is equal to 90 degrees since this OQ is perpendicular to PQ. Okay, that since tangents at any point of a circle is perpendicular to the radius through the point of contact. So therefore OR this is equal to OQ, the radius of the circle, radii of some same circle, and since OP is common side, therefore triangle PRO is congruent to triangle PQO. Hence angle RPO, this is equal to angle QPO. Okay, so by congruency by CPCT, okay, so that's O lies one side, angle bisector of PR and PQ. Okay, hence proved the center of a circle touching to intersecting lines lies on the angle bisector of the lines. Okay, now let us move to next problem. So in next problem, here we have E form an external point B of a circle with center O. Two tangents BC and BD are drawn such that angle DPC is 120 degree, and here we have to prove that BC plus BD is equal to BO, that is BO is equal to 2 times BC. Okay, so two tangents BD and BC are drawn from an external point B. Okay, and to prove that to prove that BC plus BD is equal to BO, that is BO is equal to 2 times BC. Now join OC, OD and BO. Okay, since BC and BD are tangents, and here that OC is perpendicular to BC and OD is perpendicular to BD, and we know OB is angle bisector of triangle angle DBC. Okay, so therefore angle OBC is equal to angle DBO is equal to 60 degree. So in right angle triangle OBC, here cos 60 degrees is BC by OB, and it implies 1/2 is equal to BC by AB, and it implies OB is equal to 2 times BC, and also BC is equal to BD. Okay, so tangents drawn from external point of the circle are equal, so therefore OB is equal to BC plus BC, and it implies OB is equal to BC plus BD. So OB is equal to BC plus BD, hence proved. Now let us move to next problem. So in next problem, here we have this figure. So in figure, AB and CD are common tangents to two circles of unequal radii. Okay, and here we have to prove that AB is equal to CD. Okay, so let us prove this problem. So here given AB and CD are common tangents in two circles of unequal radius. Okay, and here we have to prove AB is equal to CD. So here construction produce AB and CD to intersect at point P. Okay, so if we extend AB and CD, then they will intersect at point P. So here PA is equal to PC. The length of tangents drawn from an external point to a circle are equal, that you have studied in our previous lecture. Okay, so also PB is equal to PD. The length of tangents drawn from an external drawn from an external point to a circle are equal. Okay, therefore PA minus PB is equal to PC minus PD, and that is equal to AB is equal to CD. Okay, hence proved. Now let us move to next problem. So in next problem, here we have this figure, and in this figure AB and CD are common tangents to two circles of equal radii. Okay, so this problem we have proved this in this problem. Okay, they are actually same problem. So now let us move to next problem, problem number 7. So this is in figure common tangents AB and CD are two circles intersect at point E, and we have to prove that AB is equal to CD. So let us prove this problem. So given common tangents AB and CD are two circles intersecting at point E, and to prove that AB is equal to CD. So here EA, this is equal to EC, since the length of tangents drawn from an external point to a circle are equal. Okay, so now ED is equal to EB, same logic, and one adding this equation and one adding equation 1 and 2. Here we get EA plus EB is equal to EC plus ED, and it implies AB is equal to CD. Hence proved. Okay, now let us move to next problem. So in next problem, here we have a chord PQ of a circle is parallel to the tangent drawn at a point R of the circle. Prove that R bisects the arc PRQ. Okay, so given chord PQ is parallel to the tangent at point R. Okay, so to prove that R bisects the arc PRQ. Okay, so prove that this angle 1, this is equal to angle 2, they are equal since alternate interior angles. Okay, and angle 1 is equal to angle 3. Okay, so angle between tangents and chord is equal to angle made by chord in alternate segment, and therefore angle 2 is equal to angle 3, and it implies PR is equal to QR. Okay, and it implies PR is equal to QR. So hence proved. Now let us move to next problem. So in next problem, here we have to prove that the tangents drawn at the ends of a chord of a circle make equal angles with the chord. Okay, so let us solve this problem. So to prove angle 1 is equal to angle 2, so this angle is equal to this angle. So let PQ be a chord of a circle and tangents are drawn at the point R and Q, and here let P be the another point on the circle, and then join PQ and PR. Since at point Q there is a tangent, so angle 2, this is equal to angle P, and there is a tangent, so angle 2 is equal to angle P. Angles in alternate segments are equal, and since at point R there is a tangent, so angle 1, this is equal to angle P. Okay, and from these two equations we get angle 1 is equal to angle 2, this is equal to angle P. Okay, so hence proved. Now let us move to next problem. So in next problem, here we have to prove that a diameter AB of a circle bisects all those chords which are parallel to the tangent at the point A. Okay, so let us prove this problem. So here given AB is the diameter of the circle. Okay, and a tangent is drawn from point A, and draw a chord CD parallel to the tangent MAN. Okay, so this is a chord which is parallel to the tangent MAN, and so CD is a chord of the circle, and OA radius of the circle. So angle MAO is 90 degrees since OA is perpendicular to MA. Okay, so angle CEO, this is equal to angle MAO, and therefore angle CEO is equal to 90 degree. So therefore the OE bisects CD, perpendicular from center of circle to chord bisects the chord. Similarly, the diameter AB bisects all chords which are parallel to the tangent at the point A. Hence proved. Okay, so now let us discuss long answer type questions. Okay, so in question number 1, here we have if a hexagon A, B, C, D, E, F circumscribe a circle, so prove that AB plus CD plus EF, this is equal to BC plus D plus FA. Okay, so let us prove it. So given a hexagon A, B, C, D, E, F circumscribe a circle. Okay, so to prove that AB plus CD plus EF, this is equal to BC plus DE plus FA. So you can first of all observe this figure, and you need to prove that AB plus CD plus EF, this is equal to BC plus DE plus FA. Okay, so prove. So AB plus CD plus EF, this is equal to AQ plus QB plus CS plus SD plus EU plus UF, and this is equal to AB AP plus BR plus CR plus DT plus ET plus plus FB, and this is equal to AP plus FB plus BR plus CR plus DT plus ET. So AB plus CD plus EF plus this is equal to AF plus BC plus DE. Okay, since AQ is equal to AP, QP is equal to BR, CS is equal to CR, TS is equal to DT, and EU is equal to ET. Okay, tangents drawn from an external point to a circle are equal, and hence proved. AB plus CD plus EF, this is equal to BC plus DE plus FA. Okay, now let us move to next problem. So in next problem, here we have, let S denotes the semi-perimeter of a triangle ABC, in which BC is equal to A, CA is equal to B, and AB is equal to C. If a circle touches the sides BC, CA, AB at point D, E, F respectively, then prove that BD is equal to S minus B. Okay, prove that BD is equal to S minus B. So let us draw the figure. Okay, so this is the figure where inscribe the circle. So a circle is inscribed in the triangle ABC, which touches the BC, CA, and AB. Okay, at point D, E, and F respectively, and given here BC is equal to A, CA is equal to B, and AB is equal to C. And now by using the property, tangents are drawn from an external point to the circle are equal in length. So therefore BD is equal to BF is equal to X, say, and now BC plus CA plus AB, this is equal to A plus B plus C, and it implies BD plus DC plus CE plus EA plus AF plus FB, this is equal to A plus B plus C. Okay, and it implies X plus Y plus Y plus Z plus Z plus X is equal to A plus B plus C, and it implies A 2 times X plus Y plus Z is equal to 2 times S, and it implies S is equal to X plus Y plus Z. Okay, and it implies X is equal to S minus Y plus Z. So BD is equal to S minus B, and since B is equal to AE plus EC, Z is equal to Z plus Y. Okay, so BD is equal to S minus B, hence proved. And now let us move to next problem. So in next problem here we have, from an external point P, two tangents PA and PB are drawn to a circle with center O. At one point E, when the circle tangents is drawn which intersects PA and PB at points C and D respectively. If PA is equal to 10 cm, then find the perimeter of the triangle PCD. So let us draw the figure here first. So two tangents PA and PB are drawn from an external point P to a circle with center O. Okay, and here perimeter of triangle PCD. Triangle PCD is equal to PC plus CD plus PD. Okay, and this is equal to PC plus CE plus ED plus plus PD, and this is equal to PC plus CA plus DB plus PD, and this is equal to PA plus PB, and this is equal to 2 times PA, and this is equal to 2 times 10, that is equal to 20 centimeters. Since CE is equal to CA and D is equal to DB and PA is equal to PB, tangents from an external point to a circle are equal. Okay, now let us move to the next problem. So in next problem here we have, if AB is a chord of a circle with center O, AOC is a diameter, and AT is the tangent at point A as shown in figure. Okay, so prove that angle BAT is equal to angle ACB. So let us prove it. So since AC is a diameter line, so angle in semicircle makes an angle 90 degree. Okay, therefore in triangle ABC, angle ABC is equal to 90 degree, and here angle CAB plus angle ABC plus angle ACB is equal to 180 degree. Okay, since sum of all interior angles of any triangle is 180 degree. Okay, so it implies angle CAB plus angle ACB is equal to 180 degree minus 90 degree, and this is equal to 90 degree. Since diameter of a circle is perpendicular to the tangents, that is, since CA is perpendicular to AT, so angle CAT is equal to 90 degrees, and it implies angle CAB plus angle BAT is equal to 90 degree. And from equation 1 and 2, here angle CAB plus angle ACB is equal to angle CAB plus angle BAT. And it implies angle ACB is equal to angle BAT. Hence proved. Okay, and now let us move to next problem. So in next problem, here we have two circles with centers O and O dash of radii 3 centimeter and 4 centimeter respectively intersect at 2 points P and Q such that OP and O dash P are tangents to the two circles. Find the length of the common chord PQ. Okay, so let us find. So here two circles are of radii. OP is equal to 3 centimeter and PO dash is equal to 4 centimeter. Okay, so PO dash is 4 centimeters and OP is equal to 3 centimeter. These two circles intersect at point P and Q respectively, and here OP and PO dash are two tangents drawn at point P, and here angle OPO dash is equal to 90 degree. Tangent at any point of circle is perpendicular radius of through the point of contact, and join now OO dash and PN. Okay, then in right angle triangle OPO dash, here OO dash square is equal to OP square plus PO dash square by Pythagoras theorem. So it implies OO dash is equal to 5 centimeter. And also Pn is perpendicular to OO dash. Okay, so by Pythagoras theorem, OP square is equal to ON square plus NP square, and it implies NP square is equal to 3 square minus x square, that is equal to 9 minus x square. And in right angle triangle PNO dash, here by Pythagoras theorem, PO dash square is equal to PN square plus NO dash square. That implies 4 square is equal to PN square plus 5 minus x whole square. This implies Pn square is equal to 16 minus 5 minus x whole square. Now from equation 1 and equation 2, here 9 minus x is equal to 16 minus 5 minus x whole square, and it implies 7 plus x square is equal to 7 plus x square minus 25 plus x square minus 10x is equal to 0, and it implies 10x is equal to 18, and it implies x is equal to 1.8. Okay, again in right angle triangle OPN, 3 square is equal to 1.8 square plus NP square. So it implies NP square is equal to 5.96, and it implies NP is equal to 2.4. Okay, so NP is equal to 2.4, and therefore length of common chord PQ is equal to 2 times PN, that is equal to 2 times 2.4, and this is equal to 4.8 centimeter. Okay, so the length of the common chord is equal to 4.8 centimeter. And now let us move to next problem. So in next problem, here we have in a right angle triangle ABC is which angle B is 90 degree. A circle is drawn with AB as diameter intersecting the hypotenuse AC at point P. Prove that the tangent to the circle at P bisects the BC. Okay, so this is the figure. So here we let O be the center of the given circle, and suppose the tangent at point P meets BC at point Q. Join now BP. So to prove that BQ is equal to QC. Okay, so that is here angle ABC is equal to 90 degree. Okay, and in triangle ABC, here you can get angle 1 plus angle 5 is equal to 90 degrees, and here angle sum property. So angle 3 is equal to angle 1, and angle between tangent and the chord equals angle made by the chord in alternate segments. So therefore angle 3 plus angle 5 is 90 degree. Also angle APB is equal to 90 degrees, angle in semicircle. Okay, so it implies angle 3 plus angle 4 is 90 degree. So angle APB plus angle BPC is equal to 180 degree. Oh, linear pair. And from equation 1 and 2, we get angle 3 plus angle 5 is equal to angle 3 plus angle 4. And replace angle 5 is equal to angle 4. Also, PQ is equal to QC. Sides opposite to equal angles are equal. So it implies QP is equal to QB. Tangents drawn from an internal point to a circle are equal. So QB is equal to QC. Okay, therefore the tangent to the circle at point P at PQ bisects BC. Now let us move to next problem. So in next problem, here we have in figure tangents PQ and PR are drawn to a circle such that angle RPQ is equal to 30 degree. A chord RS is drawn parallel to the tangent PQ. Then find the angle RQS. Okay, so let us draw the figure. So this is our figure. So PQ and PR are two tangents drawn from an external point P, and therefore PR is equal to PQ. The tangents or the length of tangents drawn from an external point to a circle are equal. So it implies angle PQR is equal to angle QRP. Angle opposite to equal sides are equal. Okay, so now in triangle PQR, here angle PQR plus angle QRP is equal to plus angle RPQ is equal to 180 degree. Sum of all interior angles of any triangle is 180 degree. So it implies angle PQR plus angle PQR plus 30 degree is equal to 180 degree. So it implies 2 times angle PQR is equal to 180 degree minus 30 degree. That implies angle PQR is equal to 150 degree by 2, that is 75 degree. And since SR is parallel to QP, so therefore angle SRQ is equal to angle RQP, that is equal to 75 degree, and they are alternate interior angles, that is why they are equal. And also angle PQR is equal to angle QSR, that is equal to 75 degree by alternate segment theorem. Okay, so in triangle QRS, here angle Q plus angle R plus angle S is equal to 180 degree. Sum of all interior angles of any triangle is 180 degree. So it implies angle Q is equal to 180 degree minus 75 degree plus 75 degree. And this is equal to 30 degree. So therefore angle RQS is equal to 30 degree. Okay, so angle RQS, this is equal to 30 degree. Now let us move to next problem. So in next problem, here we have, if AB is a diameter and AC is a chord of a circle with center O such that angle BAC is 30 degree, the tangents at C intersects extended AB at a point D, then prove that BC is equal to BD. Okay, so this is the figure. So here a circle is drawn with center O and AB is a diameter. So AC is a chord such that angle BAC, this is 30 degree, and given AB is a diameter and AC is a chord of the circle with center O, and angle BAC is equal to 30 degree, and to prove that BC is equal to BD. So here angle BCD is equal to angle CAB. They are alternate segment by alternate segment theorem, and angle CAB is equal to 30 degree, that is given to us. Angle BCD is equal to 30 degree. Okay, so angle ACB is equal to 90 degree. Angle in semicircle is right angle. So in triangle ABC, here angle A plus angle B plus angle C is equal to 180 degree, and it implies 30 degree plus angle B plus 90 degree is equal to 180 degree, and it implies also angle B is equal to 60 degree. Okay, so now it implies angle CBA plus angle CBD is equal to 180 degree. So therefore angle CBD is equal to 180 degree minus 60, that is minus 120 degree, since angle CBA is equal to 60 degree, and it implies 120 degree plus angle BDC plus 30 degree is equal to 180 degree. Okay, and it implies angle BDC is equal to 30 degree. Now from this two equation 1 and equation number 2, okay, from these two equation we get angle BCD is equal to angle BDC, and it implies BC is equal to BD. Okay, so it implies BC equal to BD. So BC is equal to BD. Hence proved. So now let us move to next problem. So in next problem, here we have to prove that tangents drawn at the midpoint of an arc of a circle is parallel to the chord joining the end points of the arc. Okay, so let us solve this problem. So let midpoint of an arc AMB BM and TMT dash be the tangent to the circle, and join AB and AM and MB. Since arc AM is equal to arc MB and chord AM is equal to chord MB and AM is equal to MB, then angle MAB is equal to angle MBA, and in triangle AMB here equal sides perpendicular equals angle. Okay, so since TMT dash is a tangent line, so angle AMT, and this is equal to angle MBA. Angle since alternate segments are equal. Okay, and this is equal to angle MAB. But angle AMT and angle MBA are alternate angles, which is possible only when AB is parallel to TMT dash. Hence, the tangent drawn at the midpoint of an arc of a circle is parallel to the chord joining the end points of the arc. Hence, proof. Okay, let us solve the question number 10. So, in a figure, the common tangents AB and CD two circles with centers O and O dash intersects at point E. Prove that the points O, E, O dash are collinear. Okay, so we need to prove O, E, O dash is collinear. So here join AO, AO, OC, O dash D and O dash B. Now in triangle A, E O dash D and E O dash B. Here O dash D is equal to O dash B radius. O dash E is equal to O dash E common side. ED is equal to EV. Okay, since tangent drawn from an external point to the circle are equal in length. Okay, so here in this figure, triangle EO dash D is congruent to EO dash B. Oh, by SSS congruence rules. So it implies angle O dash ED is equal to angle O dash EB. And O dash is the angle bisector of angle DEB. Similarly, O is the angle bisector of angle AEC. Now in quadrilateral DEB O dash, angle O dash DE is equal to angle O dash B, that is equal to 90 degree. Okay, and it implies angle O dash D plus angle O dash B is equal to 180 degree, and it implies therefore angle DEB plus angle DO dash DO dash is 180 degree. Okay, since AB is right straight line, so this happened. Okay, and here this angle is 180 degree, so it implies this angle is 180 degree minus this angle, so this implies angle AED is equal to angle DO dash B. Okay, and this implies angle AED is equal to angle OAC, and it implies angle DEB is equal to 180 degree minus angle DO dash B. Okay, divided by 2 on both sides, we get angle DEB is equal to 90 degree minus 1 by 2 angle DO dash B, and it implies angle DEO dash is equal to 90 degree minus 1 by 2 angle DO dash B. Since O dash E is the angle bisector of angle DEB, that is half angle DEB is equal to angle DEO dash. Similarly, this is equal to 180 degree minus angle AOC, and divided 2 on both sides, then we get this relation. Okay, and naming this equation 6. And since O is the angle bisector of this angle, and that is half into angle AEC is equal to angle AEO. Now this angle AED plus angle DEO dash plus angle EO is equal to angle EED plus 90 degree minus 1 by 2 angle DO dash B plus 90 degree minus 1 by 2 angle OAC. And if we calculate, simplify it, then you will get basically this is equal to 180 degree. So therefore angle AEO plus angle EED plus angle DEO dash is equal to 180 degree, and so OEO is a straight line. Hence OE and O dash are collinear. Okay, hence proved. So I stop here this lecture. Thank you very much to all of you.